Now, given this triangle, we are going to find the hypotenuse, the length of the hypotenuse. Let's say this side that we have, the side on which the triangle is sitting, our base side is 3 centimeters, and the height, the vertical height, is 4 centimeters. What would the side be? Let me call it h. Now, according to the theorem, Pythagoras' theorem, it says h squared, in this case, would be equal to the sum of the squares of the other two sides. So that is 3 squares must be equal to 3 squared plus 4 squared. And so h squared is equal to 9 plus 16. Remember, we do not add 3 and 4 to give you 12 and then you square that. That's not how it goes. We square 3, write down our answer. Then we square 4, write down our answer, and then we sum both numbers. So 9 plus 16, that's 25. So we know that 25 is a perfect square. For us to solve for h, we take the square root of both sides. Now, when you take the square root of h squared, your answer is basically h. And when we take the square root of 25, we will get our answer to be equal to 5. So in this case, we realize that h is equal to 5 centimeters. And so, according to Pythagoras' theorem, 5, 3, and 4 are what we call Pythagorean triples. 3, 4, 5. Those are Pythagorean triple because they satisfy Pythagoras' theorem, with the longest side being 5, and the 3 and the 4, of course, will be the other two sides. Squaring them, adding and taking the square root will give a value of 5, which satisfies Pythagoras' theorem. Let us now look at another example as it relates to Pythagoras' theorem. So let's say we're given another triangle, right angle triangle, and the orientation of a triangle may be different, but remember, we must be able to identify the right angle. Once we can identify the right angle, then we should not have a problem finding or stating rather what the hypotenuse is. Let's say we have a right angle in which the hypotenuse, which is the opposite to the 90 degree, is 15 centimeters, and we're given another side. Let's say this side right here is 9 centimeters. What is the missing side equal to? Let us call it x. By the application of Pythagoras' theorem, it says that the square of the hypotenuse, so I will have 15 square, is equal to the sum of the squares of the other two sides, so it's equal to x all squared plus 9 all squared. And so by 15 squared we know is equal to 225, and that is equal to x squared plus 81. We are solving for x, so we must get rid of the 81 from beside it. And so we take it on the other side so we subtract it from both sides. So we have 225. It could never be added because if you add 81 to both sides, the right hand side would become bigger. And we do not want that. We want to get rid of the 81. So the only thing for us to do is to subtract 81. The opposite of addition is subtraction. So you subtract 81 from the right hand side, and that will only leave you with x squared. And if you do subtraction on the left hand and the right hand side, you also have to do it on the left hand side. It is an equation we're working. So we subtract 81 from both sides, and that is equal to x squared. Now, when we subtract 81 from 225, we end up with 144, and that is equal to x squared. Now, in order for us to solve for x, we take the square root of both sides. And so, taking the square root of both sides, we have square root of 144 is equal to the square root of x squared. And so the square root of x squared we know is equal to x. And the square root of 144 we know is 12. And so, therefore, we can draw the conclusion that our missing side is equal to 12 centimeters in unit. And that is how we apply Pythagoras' theorem. Similarly, if you are given the hypotenuse and let's say the perpendicular height of the triangle, you would carry out the same procedure to find the base side. The only time we add is when we're finding the hypotenuse. Otherwise, given the hypotenuse and another side, we would square both hypotenuse and the other given side, and then we subtract the result of the other given side from this hypotenuse result, take the square root, and that will give you the required length that we so desire. This is how we apply Pythagoras' theorem